Okay, quick look at number 10. It's a funny thing to simplify this one. I think what's the Cartesian equation of this? That just means write it in terms of x and y. You don't have to solve for y in particular. So here's one tack for doing that problem. There's multiple. If you simply just take the function, multiply both sides by r, the advantage to this is that r by itself, it's not as easy to substitute one of the equations that we have, but if you do r times r and get r squared, the cool thing is r squared is something that can be, this is one approach somebody took, was made that x squared plus y squared. That's not the approach I'm going to take, but it's something that gives you a place to go from. If you watch what I did here, this is just one way to look at it. I was looking for the fact that it was 1 over cosine squared. That's what secant squared is equal to. If you multiply both sides by cosine squared in this expression, you get r squared times cosine squared, and that is actually x squared, and so that's relatively nice to substitution. And then one that we haven't talked about much, but r is always something you can substitute with the square root of x squared plus y squared. And usually you can do plus or minus, but because x squared itself is always positive, you don't have to deal with the fact that you have a plus or minus. Usually you would put plus or minus the square root of that, but because x squared is positive, you can nix that. Now, all the other solutions that you see in the guide, they are derivations of this or just a different approach that's equivalent. So run with that. Hope that helps.